To name inorganic compounds, the first you have to master are the prefixes. One is mono, two is di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You have to know that first. The element that appears first keeps its name, while the second element ends with ide, ide. So we use prefix to show the number of atoms. So for example, the old way of naming. Let's try the compound examples. So the old ways of naming, for this one, you keep the name of the first element, this carbon. So you write carbon, and this oxide. Well, how many oxygen do we have here? We have one. So that's carbon monoxide. Carbon monoxide. For this one, we write carbon, but we have two oxygen, say dioxide. While here we have nitrogen, and because we have one oxygen, say monoxide. For this one, we have nitrogen, but because we have two oxygen, we say what? Dioxide. For this one, now we now have two nitrogen, so we say dinitrogen. Dinitrogen. Then we have four oxygen. Four is what? Tetraoxide. Then for this one, we have phosphorus. Then we have trichlorine, that's trichloride. The next one is phosphorus. 5 is what? Pentachloride. And here we have sulfur. 3 oxygen, trioxide. 3 is tri. So let's add 2 more. CuO, Cu2O. So this one we call copper monoxide. Why for this one? Dicopper monoxide. This is the old name of naming, not the IUPAC. But in some ways, sometimes it's still used because it's very fast to name. Carbon monoxide, carbon dioxide, likes. We don't use Roman numerals. We don't use IUPAC. We don't use the concept of oxidation number. So now let's move forward. I can note this first. Note this first. Now let's move forward. I'll have to clean this with the assumption that you know this already. You can note this. So for binary compounds, whereby the first is a metal and the second is a non-metal, how do we name them? For the first one, which is a metal, we just write the name normally. So this is sodium. Then this chlorine ends with IDE. So it is chloride. Sodium chloride. This magnesium oxide. So this calcium chloride. We are not using the prefixes here. This is potassium bromide, or bromide, yes. Then this one, lithium fluoride, is aluminium oxide. Let's move further. Metals with variable oxidation states, they are called transition metals. Now, if the metals you have are metals that fall between the first 20 elements, you don't have any issue. You can follow this approach. But if the metals, they are elements found after the first 20 elements, like in the case of iron, 26, copper, 29, lead, all these are not within the first 20 elements. So in this case, we have to find the oxidation number of that transition metal. For example, we have to know the oxidation state of iron here. So for this whole compound, it has no charge. So the oxidation number of a compound normally is 0. So we want to get out of iron. So here we have single oxygen O to give us the 0. So the oxidation number of oxygen is 2 minus. For metal, it doesn't have variable, so oxygen is minus 2. When this one crosses here, it becomes what? 2. So from here, it means the oxidation state of iron here is 2. So to name this, we call it right ion. Then it's used numeral inside brackets 2 right oxide. If we do the same thing from here we have 2 iron and 3 oxygen equals 0. The oxidation state of this compound is 0. We have 2 iron here, we have 3 oxygen, and each oxygen is what? Minus what? 2. 3 times minus 2 is minus 6. So everything here is what? Minus 6 equals to 0. So when I bring this 6 here, so 2Fe equals to 6. From there we get Fe to be 3. So it means the oxidation state of iron here is 3. So to name it, we call it iron 3 oxide. So now, the example we did in our first lesson, here we have 2 copper and we have oxygen equals to 0. So oxygen itself is minus 2, so put minus 2 here. When also crosses here, it becomes plus 2. If we divide both sides by 2, copper equals to 1. So that's why this one is what? Copper 1 oxide. For this one, we have 1 copper, 1 oxygen equals to 0. Oxygen itself is minus 2. When this one comes here, we get copper to equals to 2. So this one is what? Copper 2 oxide. Lead is for this lead also. For this lead here, we have 1 lead, plus we have 2 oxygen equals to 0. Oxygen is minus 2, so let's put minus 2 here. Plus 2 in minus 2 equals to 0. 2 times minus 2 is minus 4, so whatever is what? Minus 4 equals to 0. And from there we get lead to what? 4. The oxidation state of lead here is 4. So we call this one lead 4 oxide. So please always note, once the metal doesn't fall between the first strength elements, we have to find the oxidation state of that particular element or that transition metal before we can name, and we'll put that number inside this bracket in Roman numeral. That is the answer. And all the examples we have here, they are all metallic oxide. And we also have transition metallic oxide. Here, normal metallic oxide. Then what if we have non-metallic oxide? How do we name them? Alright, same thing we did here, we are going to repeat same thing here. So for example, for carbon, let's get the oxidation state of carbon. We have sulfur here, the sulfur here, nitrogen here, nitrogen, nitrogen here. So if you let me do for one, then you do the rest yourself. So here we have carbon plus 2 oxygen equals to 0. Oxygen is minus 2. 2 times minus 2 minus 4 equals to 0. And from here, we get the oxidation state of carbon to be 4. If you do the same for sulfur, you also get 4. If you do the same for this, you will get 6. If you do for this nitrogen here, you are going to get 1. If you do for nitrogen here, you get 4. If you do for nitrogen here, you get 2. So from this, we can name the following compounds using the same procedure. So the first one is carbon. Then we have 4. Carbon 4 oxide. Code name, carbon dioxide. IUPAC name, carbon 4 oxide. Same thing for this one, sulfur 4 oxide. This is sulfur 6 oxide. This is nitrogen 1 oxide, nitrogen 4 oxide, nitrogen 2 oxide. So when you call this one nitrogen 1 oxide, you're looking at our well, nitrogen is 2 here. This one is nitrogen 4 oxide. My bond, where is the 4 coming out from? This one is nitrogen 2 oxide. Where did they come out from? That is what you just learned now. Now the question is, if you are given a name, how can we get the compound? So these numbers we have here is telling us the valency or the oxidation state of that element. For example, for iron 2 oxide, I mean that iron is iron 2. We know oxide is always what? 2 minus. So if they exchange radical, the 2 cancel, we have FeO. For this one, for iron 3 oxide, that's iron 3. O is always 2 minus. They will exchange and we have what? Fe2O3. Same goes for the remaining one. For example, lead 4 oxide, it means that lead has a state of 4, oxide is 2. In the exchange, you're having what? Then 2 cancel, we have PbO2 for lead 4 oxide. So it's telling us the valency. Same thing if I'm told nitrogen 1 oxide. So that's nitrogen 1 oxide. O is 2. They were exchange, they have what? N2O, laughing gas. So I believe with this, with the name, you can get the what. Now what if you have 3 elements? Everything we're doing so far, they are all binary compounds. 2 elements, 2 elements, 2 elements. Now let's move to 3 elements. Before that, we have to take some ions. So for ternary compounds, let's first talk about ions first. That will guide us. So from OH minus, what's the name? Okay, what are the names of the following? You have to know them. So this one is called hydroxide. This one is called nitrates. This one is called nitrites. SO4 minus is called sulfate. Second one is what? Sulfite. Please note the difference. A here, I here. So for CO3, that will be what? The carbonate. While this one is hydrogen carbonate. This one is phosphate. This one is manganese, tetraoxomanganese. This one heptaoxodichromate, triazochlorate. But that is not the full name. Let's actually name them before we move to ternary compound. For example, let's try to name this. I have NO3 minus. So in this particular ion, the oxidation state is -1. So we are now going to look for that of nitrogen. So here we have nitrogen plus 3 oxygen, giving us -1. We know oxygen to be -2. So N minus 6 equals to 1. So N here equals to 6 minus 1. So therefore N equals to 5. So the name of this ion is actually trioxonitrate. Trioxonitrate. What do you have here? 5 ion. So let me do one more. Let's do for this. We have CO3, 2 minus. So for CO3, the state is -2. So we are actually for the state of carbon. Carbon plus 3 into -2 equals to -2. So C minus C equals to -2. That's 6 minus 2. C is 4. So what's the name of this? Trioxocarbonate 4 ion. Trioxocarbonate 4. That's IV. 4 ion. So for this one, it will be tetraoxosulfate. If you solve it, you get 6. This is what? Trioxosulfite. You should get what's here? 2 times 6. That's 4. This should give us, for this particular one, we have 3 elements here. So we start with this hydrogen trioxocarbonate. Then you get the IUPAC state, the oxidation state of carbon. This is tetraoxophosphate. Then you get the state of what? Phosphorus. This heptaoxodichromate, you get the state of what? Chromium. This this minus here, trioxochlorate should be 5. Trioxochlorate 5 ion. So you should be able to name any ion. You just have to look for the oxidation state of the first element if there are 2, of the elements at the center if they are 3. Please note this before we move to ternary compounds, then special compounds. Without using the IUPAC, this is sodium hydroxide, potassium nitrate, sodium carbonate, carbon carbonate, calcium carbonate, sodium sulfate, sodium sulfite, ammonium chloride, ammonium sulfate. But if you have to use IUPAC, although this one still remain sodium chloride always. Because if you look for the Heisenberg state of sodium, you get 1. And sodium is not a transition metal. So, but for this one, we have to look for the oxidation state of nitrogen here. Them down out, you do the rest yourself. KNO3. So, we want to focus on this. The answer is 0 here. K is 1. Then link for N. O is -2. -2 times 3 -6 equals to 0. So, N equals to 6 minus 1. N equals to 5. So, the name of this one is you start from this. Measure the first element first. Potassium. Then after that, you move back here, try oxo, then N is what? Nitrate, what do you have here? 5. Same here, if you get 4 carbon, you should have 4. So we start from here, sodium, neglect the prefix, try oxocarbonate, if you solve this one, you get 4. For this one, if you solve it, you also get 4. So that's calcium trioxocarbonate 4. Because calcium is 2 plus, oxygen is 2 minus. If you solve for carbon, you get 4. For this one, if you solve it, you should get 6. If you solve it out for this sulfur, you get 6. So that will be sodium tetra oxo sulfate 6. How about this one? I will not write it out to do that yourself. So this is sodium trioxo sulfate. This one should be 4. Sodium trioxo is 4. This one I didn't give you the ion before. So this ion is called what? Ammonium ion. So this one is just ammonium chloride. For this one, you have to look for the state of sulfur here. The whole ammonium is taken as a single compound. So let me just do this one as the last one. NH4, 2SO4. So we have how many NH4? We have 2 NH4. Our focus is sulfur. We have 4 oxygen. No charge, 0. This NH4 is plus, that's 1. 2 times 1, 2. S. 4 times -2, -8. So S equals to 8 minus 2. S equals to 6. So what is the answer? Ammonium tetraoxosulfate 6. So we can name ternary compounds that are non-acidic. What if they are acids? As for this one, this is a binary compound. So if binary, just write what? Hydrogen chloride. Finish. Although it's an acid, but it's binary, hydrogen chloride. But for this, same thing, we have to get the oxidation state of the element at the center. For this one, the name is ethanoic acid. And it is an organic compound, so it's not meant to be under inorganic compound. So when you get to naming of organic compounds, you do this, which is not for this level now. So if you look for the oxidation state of nitrogen here, you get 5. So ordinarily the name ought to be hydrogen trioxonitrate 5. But for acid, you don't need to mention the hydrogen. We just negate the hydrogen and write what? Trioxonitrate 5, the right acid. If you solve for sulfur, you get 6. We have H2SO4. Let's solve for sulfur. We have 2 hydrogen, and hydrogen is 1. We have 4 oxygen, oxygen -2. No charge, 0. 2 plus S minus 8 is 0. S is 8 minus 2. S is 6. So what's the answer here? We neglect the hydrogen, then just write tetraoxosulfate 6 acid. Sorry, this one ought to be 5. This one is 5 acid. This one, if you do it, you should get trioxosulfate 4. Yes. If you solve for S, you get 4 in this case. Trioxosulfate 4 acid. Tetraoxophosphate 6 acid. This one, trioxocarbonate 4 acid. So that is it. Then apart from the impact name, they also have special names. For example, this H2SO4 is known as sulfuric acid. This H2SO3 is known as what? Sulfurous acid. Sulfurous acid. So this, we also have H3PO4. So H3PO4. For H3PO4, it is called phosphoric acid. So apart from HNO3, which is called nitric acid, this is what? Nitric acid. HNO3 is called nitric acid. Then we have HNO2. We call that one nitrous acid. So nitric, nitrous, they are special names. No IUPAC name. Sulfuric acid, and this one is what? Sulfurous acid. Then apart from that, we now have important special compounds. You don't name them, so we just give them the name like that, which you have to take. Alright, on the body here, this particular one is called ammonia. We don't name it. Ammonia. This water, we don't normally name it. For this one, hydrogen peroxide. This is called methane. Why this one we call it? Although we can name this ammonium hydroxide, calcium oxide. This is calcium hydroxide, sodium hydroxide, sodium triazocarbonate 4. This sodium hydrogen triazocarbonate 4. But they also have special name. This one we call it aqueous ammonia. Aqueous ammonia, meaning ammonia that is ammonia is a gas. When ammonia is not dissolved in water, due to the dating bond, we form this is what called aqueous ammonia. So this is gas, this is liquid, you have aqueous ammonia. So this one is called quicklime, while this is called slaked lime. This is a soda, we call it a caustic soda, and here we call it washing soda. We call this one washing soda, and this one we call it baking powder, or simply baking soda. So when you see this sodium, you hear the word soda. When I say calcium, you hear the word lime. So, and we have a particular mixture, I can't recall. So I think we call it soda lime. So soda lime is actually the mixture of quicklime and slaked lime, yes, with caustic soda, I guess. So these three give us what we call soda lime. For a soda lime, it is actually a mixture, and it has a special use. Finally, we've come to the end of introduction to chemistry. Yes, we are still doing introduction. Then now let's move to atomic structure in our next class. See you. Bye. We end it here today.